All right, so the next thing we're going to look at is we're looking at example 6. Example 6 says, the table below shows the group frequency distribution of the contribution a class of 50 students made to a charity. So this this is a frequency table, and it is showing me it records the contribution, or it is an attempt to record the contribution of 50 students from a particular class, the contribution that they make to a charity. Now, what I would say here, I would start by reminding people that one, N really is equal to the sum of the frequency, F. And if I add this, I should get what? 50. Now, N is the number of values. The value here is money. It's the contribution made by each of 50 students. There are 50 students, and 50 students made a contribution to this charity. Now, since the data I'm working with is the contribution of the students, it means I should have 50 pieces of data. 50 pieces of data. All right, so under group data, so this is group data, and each one of these is called a class. Each of these, each level is called a class. Now, the first value in every group is the lower class limit. And the next value is the upper class limit. So each one of the group is called a class. The first number in every group is the lower class limit, and the next value is the upper class limit. Now, the first thing we're asked to do is A, calculate an estimate of the mean contribution made by a student. Another word for mean is average. And under group data, the mean X bar is equal to the sum of Fx divided by N. Guys, in this formula, F is the frequency and X is the class midpoint. So one of the first thing I'm going to do is I'm going to put in a table and call this table, or a column, and call this column class midpoint. Now here's how we get the class midpoint. We're going to add the lower limit plus the upper limit and divide by 2. The lower limit is 0, the upper limit is 4. 0 plus 4 is 4 over 2. The class midpoint for this class is 2. Next, it's going to be 5 plus 9 over 2. This is 14 over 2. The class midpoint here is 7. Then we have 10 plus 14 over 2. We have 24 over 2. This is 12. Now, by the third one, you don't have to keep doing this lengthy calculation. By the third one, you don't have to keep doing this lengthy calculation, because what you should observe is that the class midpoint values are going up by a fixed number. And if you're observant, you'll notice that it's going up by 5. 2 plus 5 is 7. 7 plus 5 is 12. And so the next one would be 12 plus 5, which is 17, plus 5, which is 22, plus 5, which is 27, plus 5, which is 32. Now, let me tell you what is the purpose of the class midpoint. Now, the issue with group data is that especially if you start out with the table, you do not know actual values. All I know about the contribution of the first two students is that their contribution is between $0 and $4. I do not know the actual values. But in order for me to calculate average, I must add up all the values. Now, that is a problem because I don't know the actual values. To fix that problem, what they come up with is the class midpoint. And the class midpoint now is an estimate of the value in every group, in every group. So now, rather than saying that the first two students, their contribution is between $0 and $4, we say that the first two students each contributed $2. Now, this is not 100% accurate because the class midpoint is an estimate of the value. It is not the actual value. And the reason an estimate is necessary is because we do not know the actual value. The first two students, their contribution is between $0 and $4. I do not know exactly how much each of them contribute, but as an estimate I needed an estimate so that I can calculate the mean. The estimate that we'll come up with is the class midpoint. Now, the second group of students, rather than say that these 5 students contribute between $5 and $9, we say that the 5 students each contribute $7. Now, the $7 is not accurate, but it's close enough so that we can get an estimate. The third group of students, rather than say that the 11 students contribute between $10 and $14, we say that the 11 students each contribute $12. Now, guys, so that is the class midpoint. The next thing I need to put in a column called FX. Now, FX stands for frequency times class midpoint. So this is frequency times class midpoint. This is 2 frequency times the class midpoint 2. This is 4. This is 5 times 7, 35. 11 times 12, I'm guessing that this is 132. Then 19 times 17, 9 times 22, 3 times 27, which is 81, and 1 times 32, which is 32. All right, so let's multiply 19 by 17. I'm using my calculator. Get into it. So 19 times 17 is 323. And then 9 times 22 plus 198. 198. And I need the sum of fx. So the sum of fx simply means I'm adding up all of the fx values. And let's add. We have 4 plus 35 plus 132 plus 323 plus 198 plus 81 plus 32. All right, this says 805. The sum of fx is 805. Now, let me tell you what the sum of fx represent. All right. Now, the first group is the frequency is 2 and the class midpoint is 2. Now, the frequency is the number of students, so we have 2 students. $2 is the contribution each made. So 2 times 2, that is $4. So the $4 is sort of like the sum of the contribution of these 2 students. The second group, there are 5 students and they each contributed $7. 5 times 7 is 35. So the $35 is the sum of the contribution made by these 5 students. The third group, 11 students, each contributed $12. Each contributed $12. That's $132. So the $132 is the sum of the contribution of the 11 students. Guys, it means therefore that the sum of fx is an estimate of the sum of the contribution of the 50 students. It is an estimate because the values I use in the calculation is the class midpoint. And since the class midpoint is an estimate, the sum of fx is also an estimate. So the sum of fx is $805. The mean is equal to the sum of fx over n. So it is $805 divided by n, the number of students, which is 50. This is $16.10, sorry, and 10 cents. So this is telling me that the average student made a contribution of $16.10 to the charity. Next, guys, we're told using a scale of 2 centimeters to represent 5 units on both axes, we're to draw a histogram to represent the distribution of contributions. Now, what I'm going to do is I'm going to start by labeling the graph. I should have had a little bit more space at the bottom of the graph. All right, so this is 0. Yeah, let's keep it. The scale is 2 centimeters to 5. So this is 5. Every 2 centimeters, the number goes up by 5. 5, 10, 15, 20, 25, 30, 35, 40. Now, down here is the upper class boundary. I normally like to write that out. And the class is actually contribution. All right, so let me just write that out. Down here is the upper class boundary. As I said, I normally like write out the words. And the class is actually contribution. And it is in dollars. The scale is 2 centimeters to 5 units on both axes. Let's change up something. Let's change this to maybe black. So this is 5, 10, 15, 20, 25, 30. Over here, we have the frequency. And in this question, frequency is referring to the number of students. Now, so to plot my histogram, I need the upper class boundary, and I need the frequency. We already have the frequency values. What we don't have is the upper class boundary. Now, guys, let me just show you how to get the upper class boundary. So let me just do the boundaries in general. Now, you have two types of boundaries. You have the lower class boundary, LCB, and the upper class boundary. Now, the lower class boundary, here's where you get the lower class boundary. You're going to take away 0.5 from the lower limit. The lower limit is 0. If you take away 0.5 from 0, you're going to get minus 0.5. And you're going to add 0.5 to the upper limit. The upper limit is 4. So if you add 0.5, it's going to become 4.5. Here, 4.5 to 9.5. Then 9.5 to 14.5. 14.5 to 19.5. 19.5 to 24.5. 24.5 to 29.5. 29.5 to 34.5. These are the boundaries. The first value is the lower class boundary, and the second value is the upper class boundary. All right, we can always discuss the importance of the boundary at some other point. What I want to point out here now is that to draw the histogram, I need the upper class boundary and I need the frequency. So these are the values I'm going to plot. 4.5 to 9.5 5. 14.5 11. 19.5 19. 24.5, these are my upper class boundary values, 9. 29.5 corresponds to a frequency of 3. And 34.5, the frequency is 1. These are the points I'm going to plot to draw my histogram, my group data histogram. The first value is the frequency. The second value is the upper class boundary. All right. So 4.52, 9.5. All right, 4.52, 9.55, 14.5, 11. So 2, 5, 11. All right, let's go now. We're going to plot points. Just a reminder of something. I'm going to write it, but erase it. Now, the scale here is 2 centimeters to 5 units. 2 centimeters, this is 2 centimeters. And 2 centimeters is representing 5 units. So 2 centimeters, remember guys, every centimeter on your graph sheet is divided into 10 equal parts. Sorry, every centimeter is divided into 5 equal parts. So 2 centimeters is divided into 10 equal parts. So 10 of these small division is in 2 centimeters. and that is representing 5 units. Now, if I divide both sides by 10, I'm going to get that one of these small divisions, these small divisions I'm talking about is from here to here. One of them is actually representing 5 divided by 10, 0.5 units. All right. Now, because the scale is the same on both the vertical and the horizontal axis, this is true on both the vertical and on the horizontal axis. So if 2 centimeters is representing 5 units, the 2 millimeter divisions is representing 0.5 of a unit. All right, that is something you guys should remember from when we did graphs. Now, what is the importance of that? Let's plot our points and you'll see. The first point is 4.5, 2. So we start from 0, 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. 4.5, guys, is just before 5. 4.5 corresponds to 2 going up, 0, 0.5, 1, 1.5, 2. This point is 4.5, 2. The next point is 9.5, 5. The next point is 9.5, 5. Starting from 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9. 9.5 is just before 10. 9.55 is this point. I think the next point is 14.5, 11. Starting from 10, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14. 14.5 is just before 15. And it's 14.5, 11. So this is 10, 10.5, 11. That would put my point there. Let's go to the other points. So it was 2, 5, 11. Then we have 19, 9, 3, and 1. It's 19, 9, 3, and 1. All right, so 19.5 corresponds to 19, 15, 15.5, 16, 16.5, 17. We have 15, 15.5, 16, 16.5, 17, 17.5, 18, 18.5, 19. 19.5 is just before 20. $19.5 corresponds to 19. So this is 19.5, 15, 15.5, 16, 16.5, 17, 17.5, 18, 18.5, 19. Then 24.5 corresponds to 9. 24.5, this is 5, 5.56, 6.57, 7.58, 8.59. That's the point. Then 29.5 corresponds to 3. 29.5 would be just before 30. 0, 0.51, 1.52, 2.53. And lastly, 34.5, which is just before 5, corresponds to 1. 0, 0.5, 1. So the next thing we're going to do now is we're going to draw the histogram. To draw the histogram, you're going to need your ruler because the lines must be straight. I need your undivided attention. Please pay key attention. All right. So the first bar, the height of it is 1. The second bar, the height of it is 3. So I'm going to draw my second bar. All right. So the first bar, is that bar. All right. Now, the computer didn't give me the option to make the line solid because the line wasn't long enough. At 24.5, the height was 9. So draw it up. Make the line solid. Remember, this line, you must draw it with your ruler. So now the height here, I just simply go across. So that's my first and my second bar. The next bar, the height of it is 19. This is this bar here. And when you're drawing this, you must use a ruler. Then I'll just bring the top to finish it off. We're drawing our histogram under group data. The next bar, the height is still 19. So you're gonna carry this all the way up to 19. And you're gonna just go across to finish it off. We're drawing our histogram under group data, or group data histogram. The height of the next bar is 9, so we have to be careful here not to make mistakes. All right, sorry, that wasn't 9. All right, now we have a mistake, we have to be careful. I made definitely, it's not 9, it's supposed to be 11. Okay, good, good. Correct myself. The height of this bar goes up to 11. That's the top of the bar. The next bar, the height of it is 5. All right. And the final bar. Now the issue with the final bar is where does it start? That's the issue with the final bar. All right, so the width of the bar is actually equivalent to a class width. The width of the bar is actually equal to a class width, and the class width is from the lower boundary to the upper boundary. The width of your bars is actually from the lower boundary to the upper boundary. And for the very first one, the lower boundary was minus 0.5. So that is where this thing is going to start. It's going to start at minus 0.5. So the first bar starts at minus 0.5 and the height is 2. That's the first bar. All right, so ladies and Jaden, this is your histogram under group data. And this is how it is drawn. All right, let's just take another minute to just finish up the question. C says, estimate the probability that a student selected at random would contribute at least $20 to the charity. Now, guys, at least, not so sure if I said this to you already, at least is an inequality term, and it means greater than or equal to. At least is an inequality term, and it means greater than or equal to. So what we need here is the probability that a student selected at random, that their contribution will be greater than or equal to $20. So the probability that contribution is greater than or equal to $20. To answer that, we have to go back to the table. And in looking at the table, ask ourselves, how many students had made a contribution which is either $20 or more than $20? And looking at the table, it is clear that these students, that their contribution was either $20 or more than $20. The first group contributed between $20 and $24. The second group contributed more than that, between $25 and $29. So these are the students, it's 13 of them. Their contribution, these are the total people who contributed either $20 or more than $20. And so the answer to the probability is 13 over 50, or out of 50, or 0.26, or 26%. So there's a 26% chance that if we select a student at random from the class, that student would have contributed either $20 or more to the charity.